Isometrics, most important thing in isometric is one should understand the symbols. Symbols shown over here are in double line representation. Elbows rolling 90 degree up or down is represented here. This symbol shows that elbow is rolling up and down. Whether it's going up or down, you can understand by the difference in the elevation. Next figure, if the elbow is rolling other than 90 degree, how it will be represented in the plan view. So these are the two ellipses shown in the plan view, which means that elbow is rolling other than 90 degree angle. The above two figures are double line representation. The same thing will be represented here in a single line representation. Elbow rolling 90 degree up and down. Again, if it is going up or down, you can establish by the difference in the elevation. Again, in case if the elbow is rolling other than 90 degree, this will be represented in the single line in the form of two ellipses. How symbol should be interpreted? This is the elevation view of elbow. If you draw the plan view of this, it looks like this. So you can see the circle from the top and the length shown here, this leg, and then the elbow going down, it will be represented in the form of curve. And then this is the other leg. This is the plan view of 90 degree elbow rolling down. In case if the elbow is rolling in angle, this is the elevation view of elbow going in angles. It will be represented like this in the plan view. These are the two ellipses which you can see it from the top view will be represented here in the plan view. One this ellipse, the other one is this ellipse. How to draw an isometric? This is a simple example how to draw an isometric. This is the plan view where the pipe is going in west-east direction and then it's dropping down after 3 meters. Then again it is going 4 meters, then it is going north-south, and then again it's going west-east and is connected with the gate valve. How you will represent in an isometric view? The most important thing to draw an isometric is first you need to fix the north. This is the north. You should always remember east is always on the right hand side of the north. And west is always opposite to east, and south is always opposite to north. If you represent this, if you wanted to draw this plan view into the isometric view, this is the nozzle. It is going from west to east. So here you draw the nozzle and then the check valve, and the line is going from west to east by 3 meters. This is the 3 meter line. And at 3 meters, there is a drop. Whether it's going up or down, you have to establish by checking the elevation. Here the elevation is 100 and here the elevation is 98. So it means the line is going down. So it will be represented here. The line is going down 2 meters. Remember, when the line is going up or down, it will remain same at this particular location. It will not go anywhere. Especially when the drop is 90 degree, the line remains same at the same location. So line is dropping down by 2 meters. Again, it will stay at the same location. Only the change in elevation. Now, from here again, at this elbow to the other elbow, there is a 4 meter, which is traveling in west to east direction. This is west to east direction. Then the elbow is going from north to south. So this is north to south. It is going north to south 5 meters. This is north to south 5 meters. You reach to this point. Then the pipe is going 1 meter towards east-west or west-east rather. So again, this is going west-east, and then there will be a gate wall of 600 mm dimension. This is the simple way you have to represent the isometrics. So as I explained to you in my class earlier, the isometric is drawn in 30-degree and 150-degree angles, and the vertical elevation up or down will be represented in a straight line. Let's take another example of isometrics. Here, the line is going from south to north and dropping it. It is raising up because the elevation here is 98 and here it is 100. So it is going up. Then it is going in west to east direction by 3 meters. Then again it is going from south to north direction by 6 meters. Again there is a elbow here which shows the line is dropping down because the elevation 100 here and 98 here. So it is dropping down and then it is going towards south-north by 4 meters, and then there is a gate wall and it's connected with the nozzle. How you can represent this in an isometric view? First, you need to fix the north direction. Here in this direction, you fix the north. And again, as I mentioned earlier, east is always on the right-hand side of the north. And opposite of east is west, opposite of north is south. Now the line is going from south to north. So here you start the line from south to north. This is 500 mm dimension for the check wall. Then the line is going south-north by 5 meters. This is 5 meters. Then it is going up because the elevation difference is 98 here and 100 here. So it goes up by 2 meters. So as I mentioned earlier, if the line is going up or down in 90 degrees, that line remains at the same location. Okay. Then it is going west to east by 3 meters. This is west to east by 3 meters. Then the line is going from south to north by 6 meters. Reach to this point. Again, you can see an elbow drop or up. So here you can find whether it's up or down by the elevation difference. Here the elevation is 100 and here the elevation is 98. It means the line is going down by 2 meters. And then again, it will go from south to north by 4 meters, and there will be a gate wall and the line will end here. So this is the simple way to represent isometric.